Hey everyone. Sorry I haven't been uploading the past week. School's been pretty busy and stuff. But yeah, it's Memorial Day weekend. I haven't made any Leetcode videos, but I have been doing a lot of uh Leetcode problems still every day. So I do have a lot more stuff to show you guys and stuff like that. Um, I've mostly just been doing some virtual contests because they're quite fun and yeah, I wasn't able. I wanted to do this bi-weekly and this weekly contest, but I just couldn't make it to them in time because like you have to take the contest at a certain time. So I just ended up doing them virtually, and I also did a couple others for fun. So yeah, I guess over the next couple of videos, I'll just be going over some problems from these contests. So yeah, weekly contest 243 was the most recent one. I had to do some homework and stuff, so I ended up doing this later after the contest. I only got three out of four questions correct, but I still got 329th out of 830. 8343 people, which is not bad. I would have liked to finish all four though. But yeah, I guess we'll just start off by going over the problems um, that I did manage to solve in 243. And so, yeah, I guess we'll just go over the first three problems here. Um, the fourth one is quite hard. I, I Uh, I sort of understand the solution. I spent like 5 minutes skimming over it after the virtual contest was over. But yeah, if I want to make a video, I guess I'll make like a separate video explaining that problem. But yeah, we will first go over these two problems. These three first problems. So the first problem is a really easy problem. So it's check if word equals summation of two words. So uh, yeah, I guess through these problems, I'll just be explaining the problem and the solution that I came up with during the contest. So, uh, yeah. Oh, yeah. Uh, I would have liked to make it to the contests live because I haven't really done that many because uh, I want to get my Leetcode rating up. So, yeah. Um, so, this problem says the letter or value of a letter is its position in the alphabet starting from 0. So A is 0, B is 1, C is 2. And when you can concatenate all these letters together, um, you convert that to a string, and then you can convert that to an integer. So this, since A is 0, C is 2, and B is 1, you get this string 0 to 1 and convert it in 21, right? So that's essentially the setup of the problem. It's pretty simple. And so you're given two of these strings, and you have to figure out if um, if you convert them to a number and add them up, if it equals to the third word. So in their example, uh, this CBA thing would be 210, and this thing would be uh, 21, right? And you add them together, you get this thing, so you return true because these two words add up to this word, because CDB, that's 231, right? And yeah, uh, A through J, so I'm just assuming that's 0 through 9 in the alphabet, so you don't get like a 26 or something. But yeah, so um, this problem, to solve it, you essentially just want to, it's exactly how you might want to solve it if you're a human trying to solve this problem. Just convert both of these. The idea is to convert both of these words to their number and then add them up and then see if it equals converting this word to its number. So I just have a separate method here called convert, and you basically test if converting the first word plus converting the second word equals converting the third word. And convert basically takes the string and converts it into an integer based on their rules here. So what this convert function does is it goes through every character in Word and converts it into an integer. So if you take this character and subtract a from it, an ASCII value like I don't know exactly what A is, but if you take like a character, let's say this has a value, ASCII value of like, I don't know, 97, I'm not exactly sure. This is probably wrong, but yeah, if I have like this and then I subtract like uh, another value from it, like let's just say A equals like 95 or whatever. If I do like C minus A, because these are both chars, right? Like character C minus character A, that'll give me like 2. So you can just convert characters to integer like this. So I take the character and I convert to an integer, basically how they want you to, because it's starting at A. So A is 0, B is 1. So I just subtract A from this. So A minus A would be 1, B minus A would be 2, etc. And then I just add that integer into a string builder. And then after I go through all the characters, I just return the integer representation of what we just converted. So it's pretty much exactly, this is really easy to implement. And after that, you just call convert to figure out the integer values for these two words and see if they equal the target word. So yeah, and I mean, we could convert, we could do runtime analysis. That would just be the length of all three words added together. So the word lengths are super short, so it's just pretty much constant time, pretty much because of how short the words are. And yeah, so yeah, even though it'd technically be like linear because you have to loop through all the characters in the word, but the words are just so short, you know. So yeah, when you see a really small test case in a contest, you know your solution doesn't really need to be super fast. Like it just has to work. And so, yeah, this is the first problem. It's not that hard. Um, yeah, so we'll go over the second problem now. Let me just clear this. Yeah, so this problem, let me just look at it again. Oh yeah, so this problem is the second one. It's maximum value after insertion. And so essentially you're given a string and a digit. Uh, um, yeah, so you're given a string and an integer, and you want to maximize, you want to insert this digit anywhere into the string, and which maximizes the value of the string. So that's a little confusing. It's really easy to see from the test case. So you have the string 99. You want to insert another 9 into the string somewhere to make the value as large as possible. And so here, no matter where you insert the 9, you end up with 999. And yeah, another example here would be your string is 73 and you want to insert 6 anywhere in the string. You'd want to insert it here at 700 in the middle to make 763, and it's pretty easy to see why, because if you insert 6 at the very front, like 600 something is obviously smaller than 700 something, so you want to insert the 6 after the 7, and but you don't want to insert it after the 3 because it's larger, right? And another part of the problem is that n can be a negative number, but as you can see, as you'll see later, the negative number part just means that we'll have to reverse our logic, because instead of trying to make the maximum value, we're trying to technically make the minimum, right? Because like if I can insert like 2 into here, you wouldn't want to make the most negative number. You'd want to make like the smallest negative number. Um, by smallest, I mean like closest to 0, right? Like you wouldn't want to make negative 763, even though that's like the biggest like absolute value. You want to just make like the smallest, like the closest to 0 value, right? So yeah, it's this one shows it off pretty well. So you want to insert 2 somewhere, but since this is negative, instead of trying to make the like the biggest number, absolute number, that would be like negative 552, right? You'd make negative 255. So yeah, that's enough rambling about the problem. So if you guys might have already started thinking about this, but you could, this is essentially a greedy problem, because we know that if the string is a positive number, we want to insert our number in the before the first value that is less than it. So that basically means if I have like 763, I mean, if I have 73 here and I want to insert 6 somewhere into it, I want to insert it before the first number that is less than it. So I check 6, again 7. 7 is not less than 6. So I know I want to put 6 after 7 somewhere to make the biggest number, because obviously if you put 6 before 7, 600 something will always be less than 700 something. So then I look again, I check 3, I'm like, oh yeah, 6 is greater than 3, so 3 is the first number that 6 is greater than, so I'll just put 6 right in front of 3, and that's your answer, 763. That makes the maximum value, and so we can just reverse this logic if n is a negative number. So for example, if we have like negative 73, we, instead of putting our number in front of the first number that's smaller than it to maximize this number here, we want to minimize this number here because it's a negative, right? So because like -1, I guess, is like technically greater than like -200, right? So we essentially want to minimize this number. So instead of putting our number in front of the first number that is smaller than it, we want to put it in front of the first number that is larger than it, right? So in this case, we would want to put 6 before 7 because we check 7. 7 is larger than 6. So we know that if we put 6 after 7, we'll get like a more negative number. And since we want the maximum number, we want a less negative number. So 600, negative 600 something is going to be greater than negative 700 something. So when you have this negative sign, instead of putting this number before the first number that is smaller than it, you just want to put it before the first number that is larger than it. And you could find this number just by doing a simple for loop, just by going through the array from, going through the string from front to start. And so, yeah, we'll see what this looks like. So this is a fairly straightforward greedy approach. So here is my solution. You could simplify this a little, but a tip in competitions is that as long as it works, you might as well just submit it and just get the points. So we know the length of the string is at most 10 to the 5, so a linear solution would do. And so yeah, so our solution is O of n, so it'll be perfectly fine. So here I just check if it's negative or not. So yeah, let's just go through the case when it's not first, because that's just the easiest to see. So we go through starting from the first character in the string all the way to the last one here, and we just we do this little number converting thing again. We check if it is a number here less than our number, and if it is, we want to insert our number in front of it, right? So we'll just substring from 0 to that index. So if you don't know substring, if you have like a digit here and not a digit, like character here and a character here, and you want to substring, so this is like 0 and 1. If you substring from 0 to 1, it'll be inclusive of this and not inclusive of this, right? So your substring will just grab all the numbers up to 1, because that's what you have here, right? So here, essentially, we found a number that is smaller than it, so that's like 7, 3. We check 3, we find that, so we substring from the start to 3, so we grab everything in front of 3, and then shove that into a string builder, and then we insert x there, and then we shove it everything after that. So n.substring I would just substring from this thing all the way to the end. So then you've effectively inserted 6 into the middle here. And then you just, it wants a string of where to insert it, so we can just return the string. And yeah, so for the case where it's negative, there's only a few differences. Instead of starting from the first one, you start from the second number, because the first one is a negative sign, so you start from the second character. You do this little converting thing, and instead of testing if it's less than, we just test if it's greater than, because we want our number to insert before the first number that's greater than it, to make the least negative number. So same logic here. Yeah, nothing really new. And we just need one more thing, because in theory, if you want to insert the number at the very end, we'll never actually return anything, because we'll never enter into this if statement. So if we've gone through all the characters in our string either in this case or this case, and we didn't insert anything, well, we know it must have to insert at the very back. So we can just concatenate x, our integer, to the end of n. So we can just return n plus x. And yeah, this is a pretty straightforward problem in terms of thinking of the solution, because there's no really there's not really like I don't know what to call it, clever trick that you have to find. It's just implementing a pretty straightforward greedy solution. And yeah, so I think that's it for the second problem. So let's go on to the third problem. Yeah, process task using servers. So this one's also a medium problem, but it was a decent bit harder. I think this one took me like 15 minutes or so. Yeah, I had like 50 minutes left for this last one, but I couldn't figure it out because the last one was actually quite tricky. Yeah, it uses two-dimensional DP, but anyway, let's talk about this problem. So process tasks using servers. So this one has quite a lot of setup to it. If my quick rundown of the problem doesn't make sense, you can always pause the video or go to the problem to read it. So yeah, we should probably zoom in a little also. Yeah, so process tasks using servers. So essentially what you have is you've given an array of servers and an array of tasks, right, that you need to do. And this server here, this just means that server 0 will have a weight of 3, server 1 will have a weight of 3, and server 2, because this is 0 indexed, right, will have a weight of 2. And this just symbolizes how long the task will take, right? So starting at time equals 0, so this task will be available at time equals 0. This one will be available at time equals 1, and etc. And if a task is available, you want to see like execute the task, right? So you want to assign it to the server with the smallest weight that is free, and if there's a tie, the smallest index, right? So we start at time equals 0. At time equals 0, this task becomes available, and since we have a free server, we'll assign it to this one because this one has the smallest weight, right? And so then our output will be this task will be assigned to server number 2, because this is server number 2, this is server number 1, and this is server number 0. It's just their index, right? And so at time equals 1, this the server finishes processing this task because this task only takes 1 second. So then this task becomes available at second 1 because each task becomes available at the their index second. So you'd want to use 2 again. But because this task takes 2 seconds to finish, server 2 will only be freed at time equals what, 3. So when you get to time equals 2, this task will become available because 0, 1, 2, index 2, this task will become available, and so you'll assign it to I guess server 0 because these two weights are tied, so you want to choose the smaller index. So yeah, and if there are no free servers, then you basically just wait, and when a server opens up, then you will assign that the task to that server. And if multiple tasks need to be assigned, just assign them in order of increasing index. So this is pretty straightforward. So you don't really need to do anything complicated there. You can essentially just have a pointer that loops through tasks that represents like the next task that needs to be queued up, right? And so your answer will be every index in this array will correspond to the index of the server that the jth task will be assigned to. So yeah, it's gonna be a little redundant, but of course here you're just saying, yeah, this task will be assigned to server 2, this task will also be assigned to server 2, this task will be assigned to server 0, etc. And so yeah, it's quite a lot of information to process like during the competition, right? Because I don't know if it's just me, but reading like long problems is kind of annoying, but it is what it is. So we can essentially approach this just by simulating it, because there's really no other way to do this. So essentially, you just want to perform a simulation that uh, like goes through time and just be like, hey, I need to process this task. It's become available, and let's assign it to the next server, right? And so yeah, so that's exactly what we try to do in our solution. So uh, and yeah, we can tell that a simulation will probably work here because what um, the length of both of them are just 10 to the 5. So because a simulation should optimally work linearly, or at least n log n, that will easily be enough time. Uh, so let's walk through how to simulate this. This code is a little bit of a mess, but yeah. We should first start by introducing these classes, which I just made to make the code more easy to think about. So we have a server class, which has a weight and an index. So the index represents like what number this server is. So like this server is 0, 1, 2, etc. And we have its weight. And then just a constructor here. So why is this important? Why do we do this? Because here, when we know, we want to assign it to the server with the smallest weight that is free, and choose, if in case of a tie, choose the server with the smallest index. So what we can do is we can have a priority queue of available servers, and we can sort them by their weight, and if their weight is tied, sort them by their index. So this priority queue here will basically be a queue of which server needs to be assigned the next task, right? So when we pull the first thing out of this queue, that's the server we're assigning our task to that we want. So this is pretty self-explanatory. This is a list of the available servers right now. And then the next thing we want to do to help us simulate this is to create a class called task. And in here, we'll have a reference to the server that is working on the task. So this server is the one working on the task. So that's what this server represents. And this integer will represent the time when this task will finish. And this is important because we want to know when our server will be available again. And so what we can also do is we can have a priority queue of tasks that sort them by their finish time. So at all times, this queue will basically hold the next tasks that will finish processing. So this is useful for us because when we want to check if at like time I, if these tasks are finished, we want to basically say, yeah, put these servers back in the available servers. So this is our answer array, nothing too special there. We go through all of our servers and we add a new server to our available servers with this is the weight of the server, and this is obviously the index. And yeah, so that's all the setup for the problem. And now it's just simulation. So we have a variable here keeping track of the next task. So this is the index of the next task. And sorry guys, I need a drink of water real quick. And this will be the time, like the current time. And so while there are more tasks to process, this is what that means. While there are more tasks to process, we want to first check if any tasks are finished at our current time. So basically, this is if there's a task in the working. So this is all the tasks that are currently being executed. If the next task to finish, the finish time is less than or equal to our current time, then we know that server finished its task, and we want to add it to our available servers, right? So yeah, this takes that task and puts its server back into our list of available servers. And yeah, so why the reason why we want to put this at the very start of our loop is because if you pay attention to the problem statement here, um, yeah, so at second 0, task 0 is added and processed using server 2 until second 1. And at second 1, server 2 becomes free. And then task 1 is added to server 2 and processed using that. So that is why it is important, because if our time equals 1, um, we want to first add server 2 back into our list of available servers, and then that way when we assign tasks, we can access this new server that just finished. So that's why we want to have this check at the very start. So this check is pretty self-explanatory, and let's move on to this. So this is assigning a task to the server. So we have our time variable, right? So this will always just represent the time that it currently is. And so basically, while there are more tasks and the next task is available, this basically means that the next task is available because the next task is the index of the next task, right? And in the problem, it says this essentially says the jth task is available from the jth second. So for example, the 0th task is available at second 0. So if we know that the next task represents the index of the next task, it also represents the time starting from which that task is available. So if our time is, if it is after 2 or the same as the time when this is available, then we know that this next task is available. And since it's available, we want to check if there's a server that we can add it to. So basically, this is if we can process the next task, so that's it's after the time when it becomes available and we have servers to use, we can take away a server from our available servers. In our answer, we want to put the index of our server that we're using, and then we want to add this to our list of tasks we're working on. So we're making use of these priority queues over here. So yeah, so this will represent that, the answer. And after we do this, we will just say, yep, we finished this task. The next task will point to the next index, right? And so, yeah, so that's this part of actually assigning a task to a server. And so the 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 only part left to do is to actually make our time variable make sense, right? So this is the base case. We just increment time, right? Because uh, since we we know we still have servers left, because this checks if the available servers is empty. So as long as we have servers left, we just want to increment time by 1, because that'll allow us to grab our next task, right? Because we incremented next task by 1, we also want to increment time by 1. So yeah, but in the case of when we don't have any more servers left, we don't want to just keep on incrementing time by 1, because that's pretty stupid, because uh, the the available servers will be empty, and we will never add anything to it, because if we take a look at the task that finishes, let's just say the next task finishes at time equals um, at whoops, let me just delete this real quick, at time equals like 100, and our time is currently like 10. Instead of incrementing time by 1 here, we can just directly skip to 100, because then we can take this task off of the working and put it back into our available servers. So then we'll be able to take this thing out of working because time is 100, so then the finish time is, of course, less than or equal to it. So then we can say, yeah, that server finished and put it back in the available servers. So, yeah, so this is how we increment time to accurately represent the simulation. Um, yeah, so this changes the time to basically keep on processing the next task, and we process every task. And when we process the task, we just remember which server processed it, and we can just return that as our answer. So yeah, that's the solution for uh, process tasks using servers. Um, it's a little complicated, but it's a pretty straightforward simulation if you just really step through all your logic really clearly. Um, because yeah, this stuff it looks complicated, but the actual what it's doing is actually fairly simple. And I should probably also mention the finish time is equal to the time plus how long that task will take. Uh, yeah, I don't think there's anything else that I need to go through in this question, because yeah, I feel like I explained all the aspects of the solution. And yeah, so that's going to be about it for this video, going over the problems that I solved in the most recent weekly contest. I'll be probably going over some more contest recaps uh, later, just making some videos for the virtual contest that I've been doing, and maybe we'll also get back to the good old single problem uh, solutions. So yeah, that's about it for this video. Thanks for watching, and I'll see you guys later. Bye.